Bright Duty. Every student matters.
Hello students, this is the third lecture of your chapter and the final lecture as well. This is a very important topic. This is the topic named electroplating. Students, you do not know what electroplating is, but you have seen examples in your daily life. You will be relating to that. Now you have bicycles at your homes. When you ride these bicycles, you must have noticed that they have very shiny handlebars. They have shiny wheel rims. For example, you have wheels. Now these rims, they are very shiny. You have handlebars such as where handle grips. These are also very shiny. Why is this? So why are the shiny handles? And gold plated jewelry is a perfect example. You have jewelry, your parents have jewelry which basically isn't made up of gold, but it has been plated with gold. It has a layer. For example, you have a substance and you have plated gold on it. It is not made up of gold, but it has a surface of gold on it. It has a layer of gold present on it. So this is what electroplating is. Basically, these are some of the applications. You will be getting into the definition as well, but this is the complete application. Basically, we cover a cheaper substance with a costly metal or a substance that has a good appearance, has good advantages, but it is very expensive. So we cannot afford the whole substance made up of gold or silver. Instead, we gold plate the substance, right? So students, here is an experiment in front of you. You will be studying about this experiment now. What is happening in this circuit? This is a battery. These are conducting wires. And then we have a solution. And we have two electrodes. Both of them are copper plates. One of the electrodes has been connected to the positive terminals and the other one has been connected to the negative terminals, right? So this is how we complete our circuit. Another part of the circuit is this copper sulfate solution. Copper sulfate solution is always blue in color. This is the identification for copper sulfate. Its formula is CuSO4. Copper sulfate, in which copper, when present in solution, it dissociates to form copper ions and sulfate ions. We will be studying about this in higher classes. Basically, this is the chemical formula of copper sulfate, and it is made up of two ions. One of them is copper, another one is sulfate. This is the anion, this is the negatively charged ion, this is the positively charged ion. We call the positively charged ion as cation and the negatively charged ion as anion. Now this is our complete circuit, a simple circuit showing electroplating basically. Now what do is you turn on the battery. As soon as you turn on the battery, the current starts flowing. We know that it is an ionic solution, so the current completely flows, right? We know that in this solution copper ions are present. Also we know that this first electrode has been connected to the positive terminal, so this is the positive electrode, right? It is the positive electrode and hence it will attract most of the negative ions. You have to learn, students, that negative attracts positive, opposites attract, so that they can cancel each other out. So this positive electrode attracts all the sulfate ions present inside the solution. So sulfate ions starts depositing here and the copper starts leaving into the solution, right? It releases copper ions into the solution. So we have enough copper ions, and because this is the negative electrode, the second electrode, that is this one, this is the negative electrode, so it basically calls out all the copper ions in the solution, right? So it calls out all the copper ions. So what do we see? As this plate, the plate 1, this is the plate 1. Plate 1 is losing all the copper ions into the solution. It is attracting all the sulfate ions. Its copper metal, the amount of copper on its surface is getting reduced, and the amount of copper on the second electrode is getting increased because all the copper ions from the solution are getting deposited on the copper plate, right students? So let us study its theory. When electric current is passed through the copper sulfate solution, it dissociates into copper and sulfate, right? This is we will be studying in class 10th as well. The free copper gets down to the electrode connected to the negative terminal, gets drawn. As I told you, this is the electrode connected to the negative terminal, the second one, and the copper is drawn to the negative electrode, because copper ions are positive in charge and the negative electrode is negative, hence they attract each other and hence the copper ions are drawn towards the negative electrode. From the other electrode, a copper plate, an equal amount of copper gets dissolved into the solution. That electrode, the electrode 1, this electrode is basically calling out the sulfate ions and releasing copper ions into the solution, right? Because it is the positive terminal, it attracts only the negative ions, it does not attract the positive ions, it releases positive ions into the solution. Now, we have a lot of copper ions in the solution and all these copper ions get deposited on the negative terminal, which is copper plate only. Thus, the loss of copper from the solution is restored as the process continues, right? As the copper ions are drawn from the solution to the negative electrode, the copper plate, that is the positive electrode, releases copper ions into the solution and maintains the balance, right? This means that copper gets transferred from one electrode to another. Clearly, as you can see, this electrode, the electrode 1, is losing copper, while this one, the second one, is gaining copper. So basically what we are seeing is the transfer of copper from one electrode to another. So simply this copper is being plated on the second copper plate, that is the negative terminal, negative electrode. So this is what we have learned from this experiment, that the metal, the copper metal from first electrode was being plated on the second electrode, that was the negative electrode, that was also a copper metal plate. So students, this is how we understand the process of electroplating. Let us study the definition now. The process of depositing a layer of any desired metal on another metal by means of electricity is known as electroplating. As you can see in this picture, here this is a key and it has been plated here by a certain metal, right? It has been plated by gold. As you can see that this is golden in color, while this is not golden, this is a dull color, but it is golden here. It means that it has been gold plated, right? There are many advantages of plating substances. They may start working better or they may have different advantages for different purposes. Let us study. So basically the definition is the process of depositing a layer of any desired metal on another material by means of electricity is called electroplating. Now, uses of electroplating. Students, electroplating is widely used in industry for coating metal objects with a thin layer of a different metal. For example, you have a metal that is very cheap. This is a cheap metal. This is very easy to afford, but it has a very dull appearance. It is not that good. It does not have a good appearance and it does not perform the actions very well. So we plate it with another metal, say gold or silver or chromium, so as to make it look different, and hence we now can afford the substance as well. Now the layer of metal deposited has some desired property. We plate that metal for some advantage only, obviously, which the metal of the object lacks. For example, we have a substance of any substance you can take. You have any cheaper metal, you have tin, right? Now, or you have lead. Now you know that lead does not have a good appearance and you need it for some props in a dance. Now what happens is this lead is gold plated and now the props become looking like gold, they become shiny. There is in front of you, there are some examples. This is a gold plated watch, this is a copper plated mug, this is a silver plated teapot, this is a silver plated goblet, and this is a chrome plated tap. So these are all the examples of electroplating. Right students, this is a very useful experiment so that we can perform different tasks with the help of different substances by only plating them. We do not need the whole metal to be gold or silver or chromium. So students, what are the examples, certain examples? Chromium plating is done on many objects such as car parts, bath taps, kitchen gas burners, bicycle handlers, wheel rims and many others. Chromium has a shiny appearance. This is the usage basically. We need chromium for a shiny appearance. It does not corrode. This is another advantage. It does not corrode easily. It resists scratches, so it is very long lasting as well. It does not catch any scratches. However, chromium is very expensive, so we cannot use the complete article of chromium only. We use a cheaper metal to make the article, and we coat it with the help of a layer of chromium, and we do that with the help of electroplating. It may not be economical to make the whole object out of chromium, so the object is made from a cheaper metal and only a coating of chromium over it is deposited. Jewelry makers electroplate. Simply we have copper metal and it can be gold plated or silver plated so as to make it look like gold or silver. So these are some examples. Also, silver and gold are electroplated on less expensive metals. For jewelry, basically we use less expensive metals and we electroplate them with gold or silver so as to make them look equally shiny or equally beautiful. Then tin cans used for storing food are made by electroplating tin onto iron. Iron can corrode, iron can react, so iron is not good for putting food items into it. So what we do is we take iron and we coat it with tin. So this tin is less reactive than iron, thus food does not come into contact with iron and is protected from getting spoiled. So the food that we keep in these containers does not get spoiled. Iron is used in bridges and automobiles to provide strength. Iron is used to provide strength. However, iron tends to corrode. Iron catches rust very fast. So a coating of zinc is deposited on iron to protect it from the corrosion and formation of rust. Now this procedure is also called as galvanization. We will be studying in class 10th about this, that we cover the iron articles with a zinc layer, the layer of zinc, and so as to prevent corrosion. This process of applying zinc on an iron article with the help of electroplating is known as galvanization. So students, now we have learnt about electroplating as well. In this chapter we basically learnt about the chemical effects of current. We got to know what kinds of liquids conduct electricity, how do they conduct electricity, what are the reasons of the conduction of electricity, and we also learnt about electroplating, how electroplating is used widely in our surroundings, why is it very important and how it is carried out. So this was all about this chapter, students. Thank you for your attention.